Hello everyone, this is Dan again, and once again we are doing some mixed exercises. We're taking some exam questions straight from a previous exam. So here is an example of something here where it says below are the graphs of f of x equals x squared plus b of x minus 3 and g of x equals a all over x plus p. It tells you where there's a turning point at c for f, passes through the x-axis at 1, 0. It says D is the intercept of both f and g, both the y-intercept, and the graphs of f and g also intersect at e and j, and tells you the vertical asymptote of g passes through the x-intercept, which is 1, 0. So first things first, it's asking for the value of p. So the value of p, because you have it as x plus p, this means that this is going to be exactly where that dashed line is. But if you remember, that dashed line is the vertical asymptote, and it passes through the x-intercept of f. The f-intercept is at 1, 0. So this means that our g of x just cannot be equal to, or doesn't have a value at x equals 1. If that's the case, then that means that our p is going to be equal to -1. So that means our g of x equals a over x minus 1. So now we go to the next question, which is show that a equals 3 and b equals 2. So let's start with b first. So we have f of x equals x squared plus bx minus 3. So we have x squared plus bx minus 3. And so what we want to do here is we know that it passes through the x-axis at 1, 0. So this means at f of 1, this should all be equal to 0. So f of 1 gives us 1 squared, which is 1, plus 1 times b is just b, minus 3, and this has to be equal to 0. So that means b equals 0 plus 3 minus 1, which is 2. So now the other thing is, we know that these two intersect at a certain point. And we also have g of x equals a over x plus p. So we know that d is the y-intercept of both of those. So if that's the y-intercept, then that means at x equals 0, they both intersect at that point. So that means g of x equals a over x minus 1. But this is also telling us that at that point, we have, or at g of 0, we have a over 0 minus 1. And this is going to be the same y-intercept as f of x. So we can see already from this right here that if we do f of 0, we'd get 0 squared is 0. 0 times b, even though b is 2, is 0. And we just got minus 3. So that means this is equal to minus 3. So then we have a over minus 1 equals minus 3. So if we multiply by -1, we get a equals 3. So let's rewrite this so that we know what we're dealing with. So our g of x is a is 3 and p is minus 1. So 3 over x minus 1. And our b is equal to 2. So we have f of x equals x squared plus 2x minus 3. Now we have both of our functions. So this should make things a little bit easier. So the next thing is find the coordinate of c. So c is the turning point. So this is going to be the minimum of f of x. Now an easy way to do this is to take the derivative of f of x and plug that equal to 0. So if we have f of x equals x squared plus 2x minus 3, then we have f prime of x equal to, this 2 comes down, and we get x to the 1. This exponent of 1 over this x over here just multiplies by 2. And then we plug this equal to 0 because this is our minimum. And so we know that subtract 2 on both sides, we get 2x equals minus 2, or x equals minus 1. So now we can plug this back into f of x, and we get f of negative 1 equals negative 1 squared plus 2 into negative 1, and then we have minus 3. So negative 1 squared is 1, minus 2, minus 3, which gives us 1 minus 2 minus 3 is 1 minus 5, which will give us negative 4. So that means coordinate of C is negative 1, comma, negative 4. Okay, so now we want to know the range of f. Well, we see that it has a minimum. So that means that the range is going to be from that point onwards. So that means we're going to have y is greater than or equal to negative 4, which we got straight from there. Now it says equation of a line through C that makes a 45 degree with a positive x-axis. So anything that makes a 45 degree with a positive x-axis has a slope of 1. So that makes that pretty easy. We know m equals 1. And now we know our point, because it has to intersect at coordinate C, is negative 1, negative 4. So we could just use point slope form for this. So it's y minus y1 equals m to x minus x1. So here we have y minus negative 4 equals 1 to x minus negative 1. So we'd have y plus 4 equals, this 1 here is not necessary, so we can just do x plus 1. So here we'd have y equals x, we're going to subtract 4 from both sides, x minus 3. Now it's asking, does that lie tangent to f? Well, it can't, because it's going through C, and C is the minimum. And in order for you to be tangent to the minimum, you would have to be horizontal. So it would need a slope of 0 to be tangent. So this is no. Okay, and it doesn't have a slope of 0. So we can say, but it has a slope of 1. So now it's saying function h of x equals f of m minus x plus q has one x-intercept at x equals 0. Determine the values of m and q. So when it says it has one intercept at x equals 0, that means that's the minimum. So let us take a look at what all of this does to our function h of x. So we remember, we go back up, we have x squared plus 2x minus 3. So f of x equals x squared plus 2x minus 3. So we plug this m minus x into x over here, and we get h of x equals m minus x squared plus 2 into m minus x minus 3, and then we have plus q. So we plug this all in, or we simplify this out. M minus x squared would give us m squared x squared I'm sorry, that is incorrect. It would give us m squared minus 2mx plus x squared. Here we have plus 2m minus 2x minus 3 plus q. But this is telling us it has one x-intercept at x equals 0. So that means that x equals 0, the function is equal to 0. So That means that we can set this all equal to 0, and now we have 0 equals, anytime you see an x, that's going to plug out to be 0, because that's where the intercept is at. So you have m squared minus 2mx turns out to be 0, x squared turns out to be 0, and we have plus 2m minus 2x turns out to be 0, minus 3 plus q. So that can help us in one regard. In the next, we want to kind of combine like terms here. So we have x squared, and so we're going to take out a minus x from this. So we have minus x into, and here, instead of having minus 2mx, we're just going to have 2m. And then over here, instead of it being minus 2x, we're going to have plus 2. And then we have the rest of this. So plus m squared plus 2m minus 3 plus q. So this just kind of puts it into a format we're familiar with. You have an x squared term, an x term, and your constants. So your constants are going to have to match up and add up to 0. In the meantime, we can take a look here. Because this has a minimum at 0, this means that it can't intersect the x-axis anywhere else. So this means that this part has to be equal to 0. So we have 2m plus 2 equal to 0. So 2m equals minus 2, because we subtract 2 from both sides. Now we divide by 2. We get m equals minus 1. So now we can plug this back in to here, and we get 0 equals minus 1 squared plus 2 into minus 1 minus 3 plus q. So here we get minus 1 squared is 1, 2 times minus 1 is minus 2, and then we have minus 3 plus q equals 0. So 1 minus 2 minus 3, we know that from before, is minus 4 plus q equals 0. So this means q has to equal to 4. So this is again how you solve some of these mixed exercises all together. There is a decent amount of work, but if you do them step by step, they aren't too bad. So if you guys have any questions on any of this, just let us know, and we'll help you out as much as we can, either through the Ask a Tutor function or during the live lesson. I will catch you guys next time.